Ohio State spends millions of dollars a year heating and cooling over 500 buildings. The question isn't how much energy they use, but why do they use so much, and how can we decrease this consumption? To answer this question, we built EcoPulse, a dashboard that analyzes Ohio State's power consumption, pointing out inefficiencies in their solutions. Let's roll into it.
We identified two main inefficiencies: poor insulation and inefficient HVAC systems. We found these by plotting energy consumption versus outside temperature for each building. This revealed a distinct V-shaped energy signature for every site, which we analyzed using ASHRAE change point regression. By mathematically isolating the slopes of the curve, we could physically diagnose the root cause of these issues. A steep heating slope signaled heat loss due to insulation failure, while a steep cooling slope, which is shown here, exposed inefficient air conditioners working overtime to combat heat stress. By identifying these issues, we're then able to provide an actionable plan, which details steps to combat these issues and how much money you'll actually save.
So when analyzing the weather data set provided, we saw that there was a solar energy and radiation metric that we could use to estimate buildings with high solar potential. So let's look at French Fieldhouse here and then navigate to the bottom. So we see here a breakdown of all the metrics here, and we used rooftop geometry shading and real campus energy demand provided with the data set, but the rooftop geometry was provided by the Google Solar API, which we used, and then we basically got that, used some box boundaries around the Columbus campus so we can get the data for the rooftop geometry, just so we can better estimate the solar potential of these buildings. And as we can see here, we made our own solar potential metric using rooftop, shade, demand match, and suitability. So that will come together and calculate a score for us here, and then that will pretty much show us the potential of this building, French Fieldhouse here, which is one of our highest potential yielding solar potential candidates. In addition to that, we also have the solar potential heat map here, and it basically just shows you what buildings around the area have high potential for solar potential, which is based on that calculated metric we used using those 4 parameters. We can go over here, and the higher color, the red, we have like this solar potential tier list here, and we have Woody Hayes Athletic Center has a great roofing that would be optimal for putting solar panels and energy.
At the end of the day, we realized that large, low-rise buildings with low energy demand outperform high-rise, energy-intensive buildings in Columbus, Ohio, in terms of solar power savings. As you can see, from the 10 low-rise buildings, they save 31 million kilowatt hours per year, $3.7 million in savings per year, and a total of 5% electricity to be offset.
In addition to the $3.7 million from solar power, we identified that through replacing old insulation, non-functional HVAC systems, we'd be able to save upwards of $2.5 million a year for Ohio State through energy consumption. This totals to around $6.2 million in savings just from these 3 insights alone.